So welcome to Security and Privacy in Cloud. I'm Jay Lavanya, Assistant Professor of CS Department. So today we are going to see is about Unit 4 and Cloud Security Design Patterns. In that particular title, we are going to discuss on the topic Introduction to Design Pattern and Cloud Bursting. So first one is that Introduction to Design Pattern. So cloud security design pattern, which is a reusable solution to common security challenges in cloud computing. And these patterns helps the architects and developers to design secure cloud applications while addressing threats, compliance, and operational security. Now let us discuss on the cloud security design patterns. So there are totally six design patterns which is available in cloud. Other than that, there are also so many available, but this particular topic we're going to discuss only these kind of six things. The first one is that identity and access management patterns, which is otherwise called as IAM pattern. So here, federated identity will be there. So it uses third-party identity providers like IDP to enable the single sign-on across the cloud services. And second one is that role-based access control, that is RBAC, which assigns permissions based on the user roles to enforce the principle of least privilege. The next one is that attribute-based access control, which grants access based on the attributes like user location, device type, or the time of access. And next is that if you discuss on the IAM, there is a multi-factor authentication which requires multiple verification factors to strengthen the authentication. Second one is that data protection patterns. So here deals with the data encryption, which encrypts the data at rest and in transit using strong cryptographic algorithms. And tokenization, there it replaces the sensitive data with some unique identifiers or the tokens to reduce some exposure. And the masking and anonymization is that hides or alters some sensitive data in non-production environment. And secure storage, it uses cloud provider services like AWS KMS or Azure Key Vault for key management. And third one, it's a network security patterns. So here it has some zero trust architecture where it requires some continuous verification of identity and device security before granting some access. And macro segmentation, so here it divides the networks into isolated segments to limit the lateral movements of threads. And secure API gateway, it protects the API endpoints using some rate limiting authentication and logging. And by using some VPN and private link, it ensures the secure communication between the on-premises and the cloud resources. And fourth one is that threat detection and instant response pattern. So here it uses some intrusion detection and prevention. It uses monitoring tools like AWS Guard Duty or Azure Security Center to detect some threats. And logging and monitoring, it captures the logs using some services like AWS CloudTrail or Azure Monitoring for forensic analysis. And the third one, it takes deals with some automated incident response where it implements automated playbooks using tools like AWS Lambda or Azure Logic apps. And next one is that a secure application development pattern. So here deals with some secure DevOps, DevSecOps, which integrates the security into the CI/CD pipeline using some automated security testing. And immutable infrastructure is that it ensures infrastructure is rebuilt from a secure template rather than the modified. And least privilege principle, it restricts the application access to only some necessary resources. And next one is that container security. So it uses scanning tools to detect vulnerabilities in container images. And last one is that compliance and governance pattern. So here it uses some policy as a core which enforces security policies programmatically using tools like AWS config or Azure policy, and audit and compliance monitoring, which tracks some security compliance against standards like GDPR or HIPAA and ISO 27001. And next, like data residency and sovereignty. So it ensures that the data storage and processing comply with some local regulations. So these are the cloud security design patterns. So these are the like which is commonly used in all over the industry. And apart from that, like there are so many applications or which is available in AWS. The most common thing is that they'll be like going for some targeted business or something account which is processed by the pre-processing team. Okay, so next we will see about widely used cloud design pattern. So these cloud design pattern, which is helps the architects build scalable or resilient and secure cloud applications. And these patterns are categorized into different areas based on their focus, such as scalability, reliability, security, and the cost optimization. So first one, availability and resilience pattern. So here it involves some failover pattern which redirects the traffic to a backup system when the primary system fails. And like circuit breaker pattern, it prevents system overhead by detecting the failures and stopping repeated requests to a failing service. And bulkhead pattern, which isolates some system components to prevent some failures in one component from affecting others. And retry pattern, which automatically retries failed operations with some exponential backoff to improve the reliability. And the queue-based local load leveling, here it is used like it uses some message queues to handle some spikes in traffic without some overwhelming backend services. And second one is the scalability and the performance pattern. So here it involves some auto scaling pattern which dynamically adjusts the computing resources based on the demand, and sharding pattern which divides the data into smaller partitions for distributed processing, and cache aside pattern which uses some caching layers, like example like Redis or Memcache, that is used to reduce the database load and some improves response time. And event driven pattern, it uses some event driven architectures, example AWS Lambda or Azure functions to trigger the functions on demand. And next one is that security pattern. Secure identity federation, which uses third-party identity providers, example SAML or OAuth for authentication. And what is going to be zero trust security is that it verifies every request before granting the access regardless of network location. An encrypted storage pattern which ensures all sensitive data is encrypted at rest and in transit. An API gateway pattern which secures the API endpoint with some authentication, rate limiting, and monitoring. Next one is that data management pattern. So here it uses some command query response segregation, which is otherwise called as CQRS, which separates the read and write operations to optimize the database performance. And like Saga pattern, which manages the distributed transactions in microservices using a sequence of compensating actions. And materialized view pattern, which pre-computes some query results and stores them to speed up the read operations. And next, like if you're going for some materialized view pattern, event sourcing pattern, which captures system changes as an event log, ensuring the data consistency across the services. Next one is that cost optimization pattern. Secure a spot instance pattern that uses some spot or pre-immutable instances for non-critical workload to reduce the cost. And next one is that cold storage pattern, which moves infrequently access data to low cost storage solutions, example like AWS Glacier. And serverless pattern, it uses FAAS, that is nothing but uh, function as a service to optimize the cost by paying only for execution time. And multi-tenancy pattern shares the resources across multiple customers to optimize the infrastructure cost. And last but not least is that observability and monitoring pattern. So here it uses log aggregation pattern, which collects and centralizes logs from multiple services for analysis, and distributed tracing pattern, which monitors the end-to-end requests across microservices for permissions tuning, and health check pattern, which implements the automated health checks to detect and recover from the failures. So these are the six widely commonly, or it is used in cloud design pattern. So this is like the diagram for the design pattern. So where, as I told earlier, there will be API gateway where we can able to support the web portal or the mobile app store admin or the web store friends, and it is used at the consumer end. And similarly, in API gateway, there is a API management. In enterprise service bus, which uses some service integration. Okay, and in application server, products, orders, shopping, customers, payment, inventory, fulfillment, ratings, which is under the application services. All kind of services will be provided here. And at last, in systems, data warehouse or system verifying should be done here. And next we are going to discuss is about the cloud bursting. So what is meant by cloud bursting? It is a configuration method that uses the cloud computing resources whenever on-premises infrastructure reaches the peak capacity. When organizations run out of computing resources in their internal data center, they burst the extra workload to external third-party cloud services. And cloud bursting is a convenient and cost-effective way to support the workloads with some varying demand patterns and seasonal spikes in demand. And the next topic is that cloud bursting. This is a diagram where you could see there's a configuration between the spike in traffic and the hosted application, which will be provided by the organization. And in turn, it will be moved to private cloud. There, the user base, they'll be just going through it. And that the work done by the cloud bursting application. And then in turn, it moves to the public cloud. And that's the spike in traffic will be happening here. Uh, why no it's cloud bursting is important. So traditionally organizations purchase and maintain their own computing infrastructure such as servers, storage devices, and network hardware in a private data center or co-location facility. However, with the advent of third-party cloud providers like Amazon Web Services, organizations can now use publicly available computing infrastructure that is secure, which can easily scale up or down to meet the workload demands and is available in many regions around the world. It became more convenient to use infrastructure that was fully managed by the others. The term public cloud emerged to differentiate between the internal infrastructure and the external third-party cloud resources. And many organizations, they want to continue using the existing on-premises computing infrastructure and also get the benefits of the public cloud. So they don't go for some other than per se, they'll be just using the on-premises thing so that they can deploy a cloud bursting hybrid cloud architecture to access the cloud public cloud resources when they have no more on-premises compute capacity. So by completing implementing these kind of cloud computing techniques. So cloud consumers do the following, like they uses local resources efficiently and they reduce the further investment in on-premises infrastructure cost. And third one, they can able to enjoy the scale which is provided by the public cloud. And to avoid some service interruption to business critical application due to some sudden workload hike. Okay, so these are why the cloud computing is commonly used. And next one, we will see about the some of the examples of cloud computing. I mean bursting. So what is meant by marketing campaign? Like product launches or seasonal sales. What they'll be doing is that a marketing campaign generates a huge traffic. In fact, the subsides after the event ends, right? So although your on-premise resource capacity might be adequate at other times, it might not be able to manage the overflow traffic. So you can use cloud computing to meet some peak demands at these times without having to purchase some extra computing resources. And second example is that big data analytics. So here, the big data modeling tasks such as 3D rendering or machine learning often requires more resources like the processor capacity or the internal memory because these tasks are not the norm because they are suited for the cloud burst for the public cloud. Public cloud providers also have specially optimized resources for big data analytics and artificial intelligence tasks. And before going to the types of cloud bursting architecture, I'll just show how does this cloud bursting work. The IT administrators, what they'll be doing is that they'll be configuring the capacity limit of their on-premises computing resources. When an application's workload reaches the limit, the application switches to using public cloud resources or the load balancer technology redirects incoming requests for the application to the cloud and so on. So what are the types of cloud bursting architecture is that a manual bursting and then automated bursting. So manual bursting is that it is a cloud bursting method which you can use to manually provision and deprovision some public cloud services as needed. And load balancing software monitors the resources used and sends alters that you can act on manually like advantage and like pros and cons. If you take organizations use manual bursting to create large but temporary cloud deployment for some specific tasks, or manual bursting helps test new cloud bursting projects. However, it increases the risk of human error and deployment oversights. And automated bursting here, it uses some cloud bursting tools to automatically provision resources from your public cloud provider. You can set up the policies that define how the tools handles the greater demand. The tools dynamically provisions cloud resources when they are required and deprovisions when the demand falls. Like pros and cons, if you take automated cloud bursting tools can automatically create or grow, shrink, or remove some cloud resources. So they reduce the risk of human error and efficiently use both your public and on-premises infrastructure. And other like there is a distributed load balancing. So in distributed load balancing, which is a cloud bursting approach, okay, that operates workloads simultaneously between the public cloud infrastructure and your data center. You have to set up your standby deployment in the public cloud with some minimum capacity. You also have to set some loads thresholds on your premises infrastructure and distribute them as needed. And this load balancing operations, which shares the traffic between your on-premises infrastructure and public cloud, which automatically scale up standby deployment to deal with some greater loads. Okay. Uh, Next one, how can the organizations implement the cloud bursting effectively? So to implement the cloud bursting effectively, organization requires the following features. First one, visibility. Second one, efficiency. Third one, control. So what is meant by visibility? So visibility in cloud bursting here, it shows or it should include some granular visibility to fine tune the bursting. By monitoring the resources used in detail, organizations can overcome complexities and increase their hybrid cloud capabilities. And efficiency, Organizations need to implement software and tools that can automatically orchestrate cloud computing resources. Manual balancing is effective only for some small businesses or some operations or some use cases, right? And organizations need to implement automation if they want to scale effectively. And what is in the control is that here you have to monitor the capability to track some resources and ensure that they are properly provisioned without some service interruption, especially during some peak demand times. And cloud busting tools and services that implement monitoring and reporting, which reduces the cost and increases the efficiency over time. Okay, so this is why organizations will be implementing the cloud burst. And how you can implement the cloud bursting on AWS is that, so AWS hybrid cloud delivers a consistent AWS experience between on-premises and AWS cloud resources. Select from the broadest set of services to build cloud bursting architecture that meet your specific requirements and use cases. So cloud services which include or it selects from the broadest set of services to build some cloud bursting architecture that meet your specific requirements and use cases, and cloud services which include some compute or networking, storage, security, identity, data integration, management, monitoring, and operation services. So this is how we can able to implement the cloud bursting on AWS. And so what are the examples of cloud bursting, like e-commerce website which experiences a holiday sale or financial institution? And the benefit like scalability, cost efficiency, and then flexibility. And scalability, like cloud bursting provides the ability to quickly scale the resources up and down to meet the fluctuating demands, ensuring that applications remains during peak period. Cost efficiencies, organizations can avoid over provisioning resources in the private cloud by leveraging the on-demand capabilities of the public cloud, paying only for the resources used during peak periods. And flexibility, cloud bursting allows organizations to adapt to changing business needs and handle unexpected spikes in workload without significant infrastructure investment. So next we will see about how does it works in Google Cloud. So in real time we have to work it, right? Like internet applications, it will be experiencing the extreme fluctuations in usage, while most enterprises don't face this challenge. So like these kind of things, we have to go for the bursty workloads in a data center, like cloud environments by operation resources. With batch jobs, you can optimize use by stretching the execution over longer time. So idea of the cloud-based pattern is used to private so computing environment to the baseline, load and burst to the cloud temporarily when you need extra capacity. So the design consideration you have to take while going for this cloud bursting is that you can route some incoming user request to a load balancer that runs in the existing data center, and then have the load balancer distribute requests across the local and cloud resources. Okay. If you intend to shut down the Google Cloud resources during times of low demand using the DNS routing policies, primarily for traffic load balancing, might not always be optimal. So this is mainly because resources can require some time to ensure before they can serve some users. Okay. So that is why we are going for this cloud bursting. So what about a cloud design pattern? So as we have discussed in this video about the cloud design pattern and where we have used these kind of cloud design pattern, or what are the architecture of it, and what are the common principles of using cloud design pattern, and why it is important, right? And what are the main use cases we dealt with? Yes, and there are 23 design patterns. Okay, and like when compared to all other design pattern, I can able to say like adapt design pattern, observer, strategy. There are so many design patterns uh, which is involved in the cloud application, and that is used in Microsoft as well as in the AWS platforms. Okay, and then like we have discussed about the cloud bursting, right? So cloud bursting also, we dealt with so many constraints, and we have seen about the architecture and something like that. And what is that? Uh, it shows some basic things which has to be replicated in the, and like difference if you take like cloud bursting and not the cloud scaling. These two approaches which is used to manage some varying workloads in complete cloud computing, and it is handled some unpredictable spikes, and it is more suitable for some steady growth patterns. So thank you all. I hope this video gives you information of the cloud design pattern and the cloud bursting. Thank you.